Welcome back to the Math Professors. If you enjoy content that can be found in any college math class, please consider liking, subscribing, and sharing. I'm Professor Van Hamlin, and I'm going to cover the derivative of a function at a point. So, the derivative of a function at a point x equals x naught, an interval I, is given by f prime of x naught, which will be the limit as the limit as h approaches 0 of f of x naught plus h minus f of x naught all divided by h. And really, what does that mean? Well, what we're trying to do is we're trying to find really the slope of a function at a particular point. And when we study lines, say in like pre-calculus, we know that lines have this constant slope. But if you look at, other curves in general, their slope changes depending on what point they're at. So right now, if I'm talking about the point x is equal to x naught, I'm really trying to find the slope of its tangent line at that particular spot. And the slope of its tangent line would be, it would be this right here. So we're talking about the slope of this line right here. So that would be considered, this is its tangent line. But I can't find the slope of its tangent line really with, finding the slope like I did in pre-calculus. So what I need is another point in order to find the slope of a line. So let's call this next point over here, let's call this x naught plus a little bit more. So x naught plus h. Now, if I have, a point that is a solution point of that curve, I could now find the slope of this thing using this. So let's go. So I could find the slope of what's called its secant line. So that's this piece right here. Now, this is considered a secant line because it goes through 2 points as opposed to 1 point. Now, in order to find the slope of that secant line, and it's getting messy now, but what I need to do is I need to plot these values up. So, if I plot x naught up to the blue curve f, this is now going to be equal to, f of that x naught. So this would be f evaluated at its points. And then similar, if I plug in x naught plus h into this, into this f curve, over here we're going to have f of its input as well. What I mean by that is this first input is going to give us f of x, and this second input is going to give us f of x naught. And this would be f of x naught plus h. Now, if I want to find the slope of this secant line, what we know is this thing's slope, we'll call it change in y over change in x, is going to be equal to, y2 minus y1 over x2 minus x1. And, this being let's call this one the second point because this x value comes after. So this will be our y2, which is going to be equal to f of x naught plus h, minus your y1, which is going to be f of x naught. And this is all over, x2 minus x naught. Sorry, x naught minus, this is going to be x2 is going to be x naught plus h minus, your x1, which is going to be equal to x naught. Now remember that, your y2 and y1, your x2 and x1, they don't have to come in order from this way to this way. That these are solution points x1 comma y1 and, x2 comma y2. So, this point right here being my second point is going to have this y value and this x value. And this point over here being my first point is going to have, this y value and this x value. And that's why they came in that order, These have to be points, and same thing here. All right. Now what we can see is if I simplify this, what's called the difference quotient, it ends up simplifying to, this piece right here. You'll see that those x naughts will cancel. And what we'll get is we'll just get h on the bottom. So why the limits? Why do we have this limited here? Well, remember, I'm not really trying to go after the slope of the secant line. I'm trying to go after the slope of the tangent line. So in order to do that, I don't want those points to actually be apart. I want them right next to each other. So what I'm going to do is I'm going to take this value and I'm going to slide it or make it approach x naught. And then slide this point over. Let's grab a point right here. If I use that point instead, you can see that the secant line would now look like this as opposed to the green one. And we can see that, the green one didn't have, I'm trying to get to this line here, but as I got closer, you can see that those lines are actually getting better. So as it gets infinitely close, or if I take its limits, the slope of the secant line is going to morph into the slope of the tangent line, really giving us the actual slope of the function at that point. Now, another way of writing your slope, there's other notations. We could actually say that this is the derivative of f with respect to x, and this is going to be, evaluated at that point x equals x naught. So this bar saying evaluating, or, I could say like df at x naught dx is not really the greatest of notation, but what I'm really trying to show you is that we're used to change in y over change in x, or I can say change in f over the change in x because f and y are the same thing. You can see that this derivative notation, this df dx, really is truly the expansion of the study of slope. So in the rest of this, what I'm going to do is we're going to do some examples. I'll start simple, and I was really asked to like get some algebraically messy examples in there because the only ones they're able to find are really simple ones. So I'm going to do a cubic. We'll do a radical that has extra terms in the radicand, and then we'll do like a rational function that has maybe a polynomial piece to it as well, and try to make it a little messy and not scare you off. Like we can do this. We just have to take our time. The last part of this lecture is also being able to find the tangent line to f of x at x naught. I wanted to redraw this because of it got really messy. So I'm trying to find the equation of this tangent line, and really the idea is, what things are needed. Well, remember, we're still just trying to find the equation of a line here. So in order to find the equation of a line, we know that we have that point slope form. And this is the way that we usually, write this. I know it's usually y minus y1 is equal to m times x minus x1, but we're going to use the knots because I've already got them labeled. So really, that this has, slope m, and it has a solution point of x naught comma y naught. So as long as you know its slope and its solution point, then you can find the equation of that line. So again, the solution part of the curve is right here. When I'm talking about the solution point, it's just the curve. So this point right here is your x naught comma y naught, or your x naught comma f of x naught. And remember, the slope is nothing more than the derivative. So, m is going to be equal to f prime of x naught. So you'll have all the information. So really just filling this thing out when you're done, you'll know that because of the derivative, and you'll also know the solution point. So in almost every example, we're going to find its derivative, and then we'll find the tangent line. Our example, and they'll all be like this. I'm just going to pick a function. I'm going to pick a point, and then we're going to determine the derivative of that function at that point, and then we'll determine the equation of the tangent line at that point. So what we know is f prime of x naught was equal to the limit as h approaches 0 of f of x naught plus h minus f of x naught, all divided by h. So when I want to find this thing, I need to figure out what x naught is, and then we're going to plug it into our function. So in our particular case, I want to know what is f prime of 4. So say x naught equals 4. So this is going to be equal to the limit as h approaches 0 of f of 4 plus h minus f of 4 all over h. So we're going to see in these equations, when I start changing your x naughts, this thing will stay consistent. I'm just changing this number here. This 4 might be a 1. It might be a -3. It might be something. So I'll just start changing, what point I want, and then also I'll start changing this function. So in order to fill this thing out, I have to figure out what f is, and we'll do some of the work over here because it tends to get a little messy. So let's go like f of, uh, I have to do the 4 plus h, and also note that I'm going to have to do f of 4. Let's start out with the f of 4 because you already know how to do that. So really when I plug 4 into this equation, it's everywhere there's an x, there is now a 4. So 4 squared minus 4 plus 1. So this is 3 times 16 minus 4 plus 1. So 48 minus 4 plus 1. So this will be equal to 45. Now, if I do f of 4 plus h, it's slightly more complicated because instead of having a 4 in all those locations, 4 in each one of those pieces, I'm going to have a 4 plus h there. So this is 3 times 4 plus h squared minus 4 plus h plus 1. And remember, simplifying is the same thing, as evaluation. You just go through the order of operations like this. I did the powers first, and I did multiplication second, and I added subtracted last. So similarly, 3 times, careful when you're squaring, this is 4 plus h times 4 plus h minus your 4 plus h plus 1. So, like I said, be careful. Don't distribute squares over addition. You actually have to FOIL. You have to multiply this thing. So this is 3 times first 16 outside is 4h, inside's another 4h, so that'll be 8h, and then last is going to be plus h squared minus 4 plus h plus 1. So I just squared them. Now we'll do all the multiplication. So 3 times 16 is 48 minus 24h plus 3h squared, and multiplying here, minus 4 minus h plus 1. And last, I can do all the addition and subtraction just by combining these like terms. So 3h squared minus, we got 24 and another minus 1h. So this is 25h. And then we have 48 minus 4 is 44 plus 1 is 45. So again, we have to know what is f of 4 plus h. Well, that's right here. What is f of 4? That's right here. So plugging these in, this is going to be the limit as h approaches 0 of 3h squared minus 25h plus 45. And I also have to do minus your f of 4, which is going to be 45. And then finally, this is all over h. Now, we can see that a little bit of stuff simplifies. So the 45 goes away. And now what I can do here is, since everything up here has an h, I can factor an h out. So this would be 3h minus 25 all over h. And now that the h is canceled, and this function is now defined at h is equal to 0, so we can plug in 0. 3 times 0 minus 25 is going to be equal to negative 25. So what does the derivative represent? Remember that it represents the slope of the tangent line. So now I know that this represents the slope of the tangent line. We can find that tangent line. So, tangent line. Again, what is needed? Well, we need the slope, and we have that. So our slope is going to be, f prime of 4 is going to be equal to 25. So that slope is going to be equal to negative 25. And we also need our solution point. Now the solution point is going to be equal to, remember this is x naught comma f of x naught being 4. F of x naught, we already did this, f of 4 was equal to 45, so this is going to be equal to 45. And now we're almost done. We can say y minus y naught is equal to m times x minus x naught. So another way of writing this is I can send that to the other side because I want to show you a formula that they tend to write, and it scares students. So when we plug this in, we have y is equal to m is going to be equal to negative 25, x minus 4, and then we have plus 45. So simplifying this is minus 25x, negative 25 times negative 4 is going to be plus 100. And we have plus 45. So the equation of this tangent line is going to be equal to this. Now, the formula I was saying is a lot of times what you'll see is y is equal to, they'll say this is f prime of x naught, because remember, that is your slope, which is going to be equal to your m. And then we have your x minus x naught. And then finally, instead of saying plus y naught, what they'll say is that is actually f of x naught. So the slope comes from the derivative, and then your solution point is x naught comma f of x naught. All right, time for cubic. So here's our second example. Determine the derivative of f of x, which is equal to x cubed minus 2x plus 6 at x naught is equal to -1. We'll also determine the equation of the tangent line at that point. So again, this is a definition for our derivative, which is going to give us the slope of this tangent line. So we want f prime of x naught, which is going to be -1. So this is the limit as h approaches 0 of f of -1 plus h minus f of -1 all over h. So again, what we're going to have to do is we have to evaluate the function at -1 plus h, and also evaluate the function at -1. So let's do that work over here, especially since a cubic is a little messy. So plus h. So this is, everywhere there's an x, there's a -1 plus h, minus 2 times -1 plus h, plus 6. So again, powers first, then multiplication, and then combine like terms, and so on for addition and subtraction. So -1 plus h, -1 plus h, -1 plus h, minus 2 times -1 plus h, plus 6. Now I'm going to do, I'm going to have to multiply those two binomials first. So first is going to be 1. Outside's a negative h, inside's a negative h, so this is minus 2h. And last is going to be h times h, which is h squared. We still have this binomial -1 plus h, minus 2 times -1 plus h plus 6. Okay, let's multiply these two together now. So remember, this is going to be this trinomial over this binomial. So we really have to take this trinomial, multiply it by -1, and then this trinomial, multiply it by h. So everything times -1 is just going to change its sign. So plus 2h minus h squared. Now all these things times h is just going to put an extra factor of h in each one of these terms. 2h squared plus h cubed. So that I just cubed it. Now we still have to multiply here. So minus 2 times -1 is going to be positive 2, and then minus 2h, and then we have plus 6. And then I'm going to combine some like terms. So we'll just kind of put this in descending order. So h cubed. How about the squares? I have a -h squared and -h squared. So this is a minus 3h squared. And then the linear terms, 2h plus h is going to be 3h. Minus another 2h, which is just going to be plus h. And last, I'm going to have my constant, so -1 plus 2 is going to be 1, plus 6 is going to be 7. Okay, now f of just -1. So this is going to be equal to, -1 cubed minus 2 times -1 plus 6. So -1 times -1 times -1 is -1. Negative times negative would be a positive 2 plus 6. So this is going to be 7. All right, plugging these in. We know we have this, which is this trinomial here. Oh, sorry, this forward term. So we're going to have a limit as h approaches 0 of h cubed minus 3h squared plus h plus 7 minus, we still have to do f of -1, so minus the 7. And this is all going to be over h. Now, very similarly, we can see that those 7s are gone. And then all these terms have an h in them, so I can factor out an h. So an h, I'm going to have h squared minus 3h plus 1 all over h. Canceling my h. This function is now defined at 0, so I can plug in 0. So this would be 0 squared minus 3 times 0 plus 1, which is going to be equal to 1. So the slope of the tangent line at -1 is going to be equal to +1. And I'll do our tangent line. So we know that our tangent line, using the point slope form, is going to be your slope, which is the derivative, x minus x naught, which is our given point, and then f of x naught, which is going to give us our y value. So this is going to be equal to m being 1, x minus a minus 1, so x plus 1, and then plus y naught. Remember that we already found f of negative 1, which is equal to that 7, so plus 7. So then when we're done here, this is going to be equal to x plus 1 plus 7, which is going to be equal to x plus 8. Now let's do we're gonna do a radical that'll be a little messier than just say the square root of x, but just slightly more messy. So our third example, we're going to find the derivative of this radical. So 2 times the square root of the quantity 12 minus x plus 1 at x naught, which is going to be equal to 3. So again, finding its derivative. We want to know what is f prime of 3. So limit as h approaches 0 of f of 3 plus h minus f of 3 all over h. Now, again, I'm going to have to evaluate this function at 3 plus h. So this is 2 times the square root of 12 minus, be careful here, I'm subtracting, so this is going to be 3 plus h in parentheses. Don't forget, you got to distribute that negative, plus 1. So this is going to be equal to 2 times the square root of, well, 12 minus 3 is going to be 9, and then we're going to have a minus h, and then plus 1. Now I'm also going to have to find f of, just 3. So this is going to be 2 square root of 12 minus 3 plus 1. So this is 2 times the square root of 9 plus 1. So 2 times 3 is 6 plus 1 is 7. So again, I know f of 3 plus h, I know f of 3, and we're going to plug them in. So limit as h approaches 0. So this is 2 times the square root of 9 minus h plus 1, and I have minus this 7, and this is all going to be over h. So what I want to do is I'm going to simplify this as much as I can before I use the technique that's used with radicals. So we'll talk about it momentarily. So all I know is minus 1 plus 7 is going to be minus 6 all over h. Now, the radicals are done differently. The way you simplify a radical, or the way you can say you factor a radical, is we use its conjugate. So what I'm going to do is I'm going to multiply top and bottom by the conjugate of the numerator, which really just means instead of having this minus sign here, we're going to have a plus sign there instead. So this is 2 square root of 9 minus h plus 6, and then the same thing on the bottom, 9 minus h plus 6. So we will FOIL those numerators. So first, well, what we're going to have is 2 times 2, which is going to be equal to 4. And then we have the square root of 9 minus h times the square root of 9 minus h, which is going to give us the square root of 9 minus h all squared. So the square roots really are just going to cancel. This is just going to be 9 minus h. Now, notice I have parentheses in there. Don't just say 4 times 9 and then minus an h. This has to be 4 times whatever you get here as well. So make sure you're multiplying this entire thing by 4. So that's first. Now, outside, this is going to be 2 times 6, so we're going to have 12 times the square root of 9 minus h. Inside actually is going to give us almost the same thing, but it's opposite. 9 minus h. And then last, I'm going to have a negative times a positive, so this is a negative 6 times 6, which is 36. And then our denominator, I'm not going to expand it like I did above. I don't want to hide that factor of h. That's the thing I'm trying to cancel. So I'm just going to write those two factors next to each other. And then we know this stuff is going to simplify quite nicely. So first things first is we can see that outside and inside cancel. That's why we're doing conjugates. And next we can see that this is going to be kind of nice too, because when I multiply, this is going to be equal to, let's put it over here, this is the limit as h approaches 0 of 36 minus h minus 36 all over this h times 2 root 9 minus h. plus 6. And those 36 are going to cancel. And I don't like to cancel right away after that, too, because it might confuse students. So this is going to be the limit as h approaches 0 of, now I have this negative h over this h times that quantity 2 roots 9 minus h plus 6. And now what we can see is those h's will cancel. So we'll have a negative 1 in the numerator. And notice that this thing is now defined at h is equal to 0, so we will plug that in. So this is going to be equal to minus 1, evaluated at 0 is going to be 2 times the square root of root 9 minus 0, quantity 9 minus 0, and then we're going to have plus 6. Simplifying this is going to be just root 9, which is going to be 3. So negative 1, this is going to be 2 times 3 plus 6. So this is going to be equal to negative 1 over 12. And that right there is our derivative at 3. Now again, we can find the equation of the tangent line. So the equation of the tangent line, slope comes from the derivative at 3. And then I have this x minus 3 because I'm going through x naught, which is equal to 3. And then the y value when you plug in 3. So m, our slope, is going to be this negative 1 over 12. X minus that evaluation point plus f of 3. And we already know that f of 3 was 7. I've already evaluated this, so this is equal to 7. So we can clean this up. This is minus 1/12 x. Minus, well, this is going to become, a negative 3 over, negative 12. So this is going to become a fourth. So plus a fourth. And then plus 7. Now, in order to add these things, it would be nicer if this 7 was in fourths. So we're going to cross that out and say this is 28 over 4. And now adding those like terms, x, this is going to be plus 29 over 4. And that is the slope of the tangent line for this radical at x equals 3. So our last example, we're going to do a rational that's a little messy as well, just to get you used to this algebra. So our last derivative is going to be this function here. So you can see that I have, kind of polynomial mixed with a rational term in there, and really just to try to show you that it's not that scary. Like, we do the same things. This is going to be f prime at 2 is going to be the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. So our f of 2 plus h. Everywhere there's an x, there's now a 2 plus h. So simplifying this is going to be 10 plus 5h minus 4 over 2 plus h plus 1. And I'll combine the 10 and the 1 to give us 11 plus 5h minus 4 all over 2 plus h. And then we'll also do f of 2. So this is 5 times 2 minus 4 over 2 plus 1. So this will be 10 minus 2 plus 1. So we got 9. Okay. Now, plugging these into the expression over here, this is going to be the limit as h approaches 0. Well, after 2 plus h is that 11 plus 5h minus 4 over 2 plus h minus this 9 all over h. Okay, now the question is what do we do with this expression? Well, I can simplify this right away. I have 11 minus 9, which is going to give us 2, and we'll go ahead and do that and leave myself some room here because when you have rationals, we have common denominators is how we're going to do this. So this is going to be 2 plus 5h minus this 4 over 2 plus h. and this is all over h. I left myself some room here because I know I'm going to have to combine these rationals, and in order to do that, they have to have the same denominator, so that denominator being this one right here, this 2 plus h. So I'm going to multiply this 2 by 2 plus h over 2 plus h. So top and bottom by the same thing. Let's do it this way. Similar here. This is going to be 2 plus h over 2 plus h. Now, when we're adding these fractions, what we know we can do is, so when you're adding these fractions, what we know we can do is this is all going to be over h still. But when I add these three terms, I'm going to have a 2 plus h in the denominator because we know when we add or subtract fractions that the operation happens in the numerator, and you keep that common denominator. So, this new numerator here is going to be 2 times 2, which is 4. So 2 times 2 and also 2 times h. So this is going to be 4 plus 2h. Similar here. 5h times 2 and 5h times h. So 5h times 2 is going to be 10h, and then 5h times h is going to be plus 5h squared. And then last, I'm going to have this minus 4. And I'm going to try to keep this denominator bigger because really it's this numerator over this h. So we'll clean up this numerator first, and we can see that. Well, look at this. 4's go away. Now, in order to take this complex fraction, which is this fraction over this h, is really what I have here. Is I have this h over 1, and we're doing this. We're doing this division here. This division. So when we want to rewrite this, we just rewrite that division as equivalent multiplication. So this is going to be the limit as h approaches 0 of you have 2h plus 10h plus 5h squared all over our 2 plus h. And then when I do this division, it's going to become multiplication by this thing's reciprocal, which is going to be a 1 over h. Notice everything's got an h in the top. So this is going to be the limit as h approaches 0. Factoring out that h, I'm going to have 2 plus 10. Could have combined those, huh? I should have. I should have just wrote that as 12h, but it's too late now. It's 2 plus 10. And plus, is it going to bother me enough? Nah, it's fine. What I was trying to say is you could say that's 12h, right? So I could pull out an h, and this is now going to be 12, and pull an h from here, I'm going to still have a 5h, and this is all going to be over 2 plus h, but remember I've multiplied by the reciprocal of this thing over here, so we still have this times 1 over h, and we can see that these h's right here will cancel, just leaving me with this rational expression. So now when I plug in h is equal to 0, this will be 12 plus 5 times 0, all over 2 plus 0. So this would be, those will go away. This is going to be 12 over 2, which is equal to 6. So that means f prime of 2 is equal to 6. Now, I'm not going to do the tangent line for this one because I think you've seen those things enough. I just want to make sure that we can take the derivative of something that looks complicated and just using common denominators, get the job done. So if you like the videos, please consider liking, subscribing, sharing. Thank you.